Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Abdullah Ahmad bin Abdul Alim, and today I will present to you about pre-lab gas absorption unit. What is gas absorption? Gas absorption is an operation in which a gas mixture is contact with a liquid for the purpose of preferentially dissolving one or more components of the gas mixture and to provide a solution of them in the liquid, also known as scrubbing. Objective: to study the effect of water flow rate and inlet gas composition on the efficiency of CO2 absorption. To show the importance of the operation and its application in everyday life. This is a process flow diagram for the gas absorption unit. For the general description, air and carbon dioxide CO2 are mixed before being fed into the bottom of a packet absorption column, while water enters from the top of the column through a centrifugal pump. Transfer of CO2 from air mixture into water occurs when gas and liquid are brought into contact. The lean air mixture will exit at the top, whereas the CO2-rich water will accumulate at the bottom of the column and overflow into a receiving vessel. First, receiving vessel B1 and B2. 50-liter cylindrical vessel equipped with charge port and venting. Second, absorption column K1. Active packet column with glass resistive rings, inlet and outlet connection for counter-current gas and liquid flows. Effective column height is 1500 mm. Third, centrifugal pump P1. Centrifugal pump with maximum delivery rate of 60 rpm at the maximum delivery height of 6.3 meter. For the general operating procedure, prior to operation, it is important that the user read and fully understand all instructions and precautions stated in the manufacturer's manual supplied with the absorption unit. The following procedure will serve as a quick reference for operating the unit. For the general startup procedure, ensure all valves are closed except ventilation valve HV13 fully open. Drain any stagnant liquid above the sampling valve HV03, this one. Third, open the valve on the compressed air and CO2 supply line, this. Set the pressure air supply is 0.2 MPa and pressure CO2 supply is 2.0 MPa by turning the regulator knob clockwise. Turn on the main switch. For the general shutdown procedure, first turn off the pump P1. This, close valve water supply and valve HV01, HV02 and HV011. This. Drain all liquid from column K1 by opening valve HV03. Drain all liquid from receiving vessel B1 and B2 by opening valve HV07 and HV08. Close valve HV03, HV04, HV07, HV08 and HV10. Close valve HV12, HV14, HV15, HV16 and HV17. Ensure that HV13 is fully open. Turn off the main switch. CO2 analyzer procedure. First, switch on the control panel and let the system on for about 15 minutes to stabilize the system and to make sure the CO2 analyzer warming up. Second, push the reset button QT401 and QT402 on the junction box for about 2 seconds. Turn on the air compressor toolbar and let the air flow into the system. Let the system running about 5 minutes to ventilate the remaining CO2 in the analyzer. Once the reading of CO2 shows the zero value of the indicator display, the experiment is ready to run. Liquid sampling procedure. Samples can be taken from liquid entering and exiting the absorption column. Sampling valves are located at HV08 for inlet liquid to absorption column K1, HV03 for outlet liquid from absorption column K1. Step: First, drain any stagnated liquid above the sampling valve. Second, place a vial below the sampling valve. Third, open sampling valve and collect about 150 ml of sample. Lastly, close the sampling valve. Analysis of dissolved CO2 in water. First, obtain a sample from CO2 analysis procedure. Prepare exactly 50 ml of sample in a conical flask. Add 3 to 5 drops of phenolphthalein indicator. Next, if the sample turns red immediately, no free CO2 is present. If the sample remains colorless, titrate with 0.05 m NaOH standard solution. Next, measure the volume of 0.05 m NaOH required to reach the endpoint. The endpoint occurs when a definite pink color persists in the solution for longer than 30 seconds. Use a color comparison standard. Prepare exactly 100 ml of 0.01 NaHCO3 solution in a conical flask and add 3 to 5 drops of phenolphthalein indicator. How to collect data results. The samples are collected from the outlet of absorption column K1 from valve HV103. Collect approximately 100 ml at every 5 minutes. The collected samples are analyzed to determine the composition of dissolved CO2. The collected data will be included into the table in Appendix C. Repeat the experiment by using different flow rate. Plot graph CO2 concentration against time for each CO2 flow rate. The missing data is concentration of CO2. So how to obtain the missing data? Concentration of CO2, mole CO2 over volume used. The formula: concentration of CO2 M equals to mole CO2 over volume used. The expected result. I can determine the effect of water flow rate and inlet gas composition on the efficiency of CO2 absorption. Thank you.